A very good morning, students. Today we'll be learning about the ocean tides. Waves, currents and tides are of vital significance among various types of oceanic movements. Tides are, in fact, the most important of all the oceanic movements because tidal currents affect the whole water mass from the sea surface to the bottom. The rise and fall of the sea water due to the gravitational forces or the centripetal forces of the sun and the moon are called the tides. The sea waves generated by the tides are called the tidal waves. The rise of the sea water and its movement towards the coast is called the tide, and the resultant high water level is known as the high tide water. The fall of the sea water and its movement towards the sea is called the ebb. The resultant low water level is called the low tide water. The difference between high tide water and the low tide water is called the tidal range. There is much variation in the height of the high and the low tides at different places in different oceans because of varying characteristics of the depth of ocean water, configuration of the sea coasts and coastlines, and the openness or the closeness of the seas. Through this lesson, you will be able to understand what are tides, their types, time of the tides, theories of the tides and the tidal currents. The origin of tides in the oceans is primarily concerned with the gravitational forces of the sun and the moon. It may be pointed out that the earth rotates from west to east and revolves around the sun following an elliptical orbit. Similarly, the moon rotates from west to east and revolves around the earth along an elliptical orbit so that the distance between the moon and the earth changes during different times in every month. The period of the farthest distance between moon and the earth is called apogee, while the period of the nearest distance is called the perigee. Two tides and ebbs are experienced twice at every place on the earth's water surface within 24 hours. When the sun, the earth and the moon are in the same line at the time of the full moon and the new moon, their gravitational forces work together and high tides are formed. On the other hand, when the sun and the moon are at the position of the right angle with reference to the earth, the gravitational forces of the sun and the moon work against each other and hence low tides form. This situation occurs during the 8th day of each fortnight of the month. Time of the tides. On an average, every place experiences tides twice daily. Since the earth completes its rotation in roughly 24 hours, every place should experience tide after 12 hours, but this never happens. Each day, tide is delayed by 26 minutes because the moon also rotates on its axis, which revolving around the earth. Since the earth rotates from west to east and hence the tide center shifts westward. When the center completes one round, the moon's position is ahead of the tide center by the time because the moon also revolves around the earth. With the result, the tide center takes another 52 minutes to come under the moon. Thus, a particular tide center takes 24 hours 52 minutes to come under the moon, but by the time there is another tide at the opposite side of the referred tide center, this happens after every 12 hours and 26 minutes. Types of the tides. The oceanic tides are caused due to the tide production forces of the sun and the moon. There is a lot of temporal and spatial variation in the tide producing forces because of different positions of the sun and the moon with the earth. Because of the variations in the intensity of the tide producing forces, several types of tides are caused. A few important types of the tides are spring tide. Very high tide is caused when the sun, the moon and the earth are almost in the same line. Such high tides are called the spring tides. The position of the sun, moon and the earth in the straight line is called syzygy. When the sun, the moon and the earth are in sequential order in the straight line, in other words, when the sun, the moon and in the other side, in the one side of the earth, the position is called conjunction. Then the position of the earth is in between the sun and the moon. This is called opposition. On the other hand, when the sun, the earth and the moon are in the position of right angle, it's called quadrature. The positions of the conjunction and the opposition take place during the new moon and full moon respectively. In these situations, the gravitational forces of the sun and the moon work together with combined force and thus high tide is caused. The height of such spring tides is 20% more than the normal tides. Such tides occur twice every month, during the full moon and the new moon, and the timing is fixed. Neap tides. The sun, the earth and the moon come in the position of a quadrature on the 7th, 8th day of every fortnight of the month, and thus the tide producing forces of the sun and the moon work in opposite direction. With the result, low tide is caused. Such tide, which is lower in height than the normal tide, is called the neap tide. The height of the neap tides is generally 20% lower than the normal tides. Tropical and equatorial tides. Like the sun, there is also northward and southward position of the moon in relation to the equator of the earth. If the sun completes its northward and southward position in 1 year, that is in roughly 365 days, moon completes it in 27.5 days, or say in 1 synodic month. When there is a maximum declination of the moon to the north of the equator, the moon rays fall vertically on the tide centers, that is near the Tropic of Cancer, and hence spring tides are caused. Such tropical tides move westward along the Tropic of Capricorn, which is opposite to the Tropic of Cancer. Thus, successive high and low water occurring along the Tropics of Cancer and Capricorn are of unequal heights. Such tides and ebbs of higher and lower heights than the normal tides and ebbs respectively. Such tides recur twice every month when the moon's rays fall vertically on the Tropics of Cancer during the northward position of the moon and Tropic of Capricorn during the southward position of the moon. Thus, the tides occurring along the Tropics of Cancer and Capricorn are called tropical tides. There is no diurnal inequality of the tides in terms of heights of 2 neap tides and 2 spring tides because the moon is vertical on the equator every month. Such tides are called equatorial tides. Epogean and perigean tides. The nearest position of the moon with the earth is called the perigee when the distance between them is 3,56,000 kilometers. The tidal force of the moon is most powerful during this position and hence high tides are caused. Such tides, called as the perigean tides, are 15 to 20% higher than the normal tides. On the other hand, the tidal force of the moon is minimum during the position of the apogee when the moon is at the farthest distance from the earth and hence low tides are caused. Such low tides, called as epogean tides, are 20% lower than the normal tides. When the spring tide and the perigean high tide occur at the same time, the resultant tide becomes abnormal. Similarly, when the neap tide and epogean tide occur at the same time, the water level becomes significantly low. Daily and semi-diurnal tides. The tides recurring at the interval of 24 hours 52 minutes daily are called the diurnal or daily tides, while tides recurring at the interval of 12 hours 26 minutes are called semi-diurnal tides. Equinoctial spring tides. The tides recurring at an interval of 6 months due to the revolution of the earth around the sun and the sun's varying declinations are called the equatorial tides. Theories of the origin of the tides. Numerous theories have been put forth from time to time to explain the origin of the ocean tides. These theories include equilibrium theory by Isaac Newton in 1687, dynamical theory by Laplace in 1755, progressive waves theory by William Whewell 1833, canal theory by G.B. Airy 1842, stationary wave theory by R.A. Harris, etc. Equilibrium theory. Sir Isaac Newton propounded his theory of gravitation in his Principia in the year 1687, wherein he stated that every celestial body of the universe possesses gravitational force. The celestial bodies attract each other through their gravitational force in such a way that they remain in equilibrium. Thus, the Sun, the Earth and the Moon are also in equilibrium due to their respective pull towards each other. Though the gravitational force of the Sun is far greater than that of the Moon, but the lunar gravitational force has more effect on the Earth than that of the Sun because of its nearness to the Earth. The Earth and the Moon, while attracting each other, revolve around their common center of gravity, and thus two types of forces are produced. The centrifugal forces, which work outward from the center, and centripetal forces, which work towards the center. Centrifugal force is similar at all points on the Earth's surface. The Earth's surface under the Moon is 6,400 kilometers nearer to the Moon's surface than its own center, so that the centripetal or gravitational force is greater than the centrifugal force at the Earth's surface. Consequently, the water of the Earth's surface under the Moon is attracted and pulled, and high tide is caused. Gravitational and centrifugal forces balance each other along the line, joining the poles, resulting in a resultant force which is directed towards the center of the Earth. This force causes lowering of the sea level and depression, that is the low tide. It is apparent that each place experiences two high tides every day. Similarly, there are two tides on the Earth's water surface at the same time. One is caused due to the gravitational or the centripetal force being greater than the centrifugal force, while the second one is caused due to the centrifugal force being greater than the gravitational force, so that both may balance each other. It may be stated that the highest points of rise of the water or the high tides lie nearest to and farthest away from the Moon, while the lowest points of the water surface or the lowest tides lie at places perpendicular to the above places. These four phenomena, that is the two high tides and the two low tides, occur simultaneously at the same time on the Earth's surface. The limitations of this theory: since the Earth's surface is comprised of land and water, and hence the gravitational force of the Moon will not be so effective as it would have been if the Earth's surface would have been composed of only water. Secondly, the bulge of the water may not be possible unless some sort of horizontal movement of the tide is involved. In other words, changes in the position of the water masses in the form of horizontal movement are essential for the bulging of the sea water outward. In order to overcome this shortcoming, the theory was subsequently amended. The theory envisages the waves are generated during the occurrence of the tides, and these waves move westward with their crests directly under the Moon. Thirdly, the time of the high tide should be the same at all places along each meridian, but this never happens. For example, Liverpool and Leith, both are situated on the 8-degree west longitude, but the time difference of the two high tides of these two places is of 3 hours. Fourthly, the proposed theoretical time by this theory for a tidal wave to move around the Earth would be slightly more, because there is vast variation in the configuration of the course of different oceans and their depths, and thus the tidal waves have to move under internal as well as external frictions. Progressive wave theory. The progressive wave theory of William Wavell, propounded in the year 1883, and the canal theory of G.B. Airy, postulated in the year 1942 to explain the origin of the ocean tides, are based on the facts. The Earth is a heterogeneous body and not a perfect fluid. Tide occurs at different times at different places on the same longitude. There is a lagging of time of tides away from the source. There is variation in the magnitude and amplitude of the tides at different places. Tide is in the form of tidal wave which travels from east to west. The crests and the troughs of such tidal waves become tides and ebbs respectively. These waves are originated in the oceans under the influence of tidal force of the moon. The length and the velocity of the tidal waves depend on the depth of the seas and the oceans. In a globe completely surrounded by water, the tidal waves would travel freely from east to west, but the position of the land and the water hinders the velocity and the direction of these waves. Since the continents roughly stretch from north to south, and hence they hamper the free movement of the tidal waves. These waves are least hampered in the oceans surrounding the Antarctic continent. Thus, tidal waves are generated in the Southern Ocean in the southern hemisphere under the influence of tide producing forces of the moon. These waves are called primary waves, which move from east to west in the form of forced waves. These waves are obstructed by the continents and are consequently refracted northward. Secondary waves are generated when the westward movement of the primary waves is obstructed by the land masses. These northward moving waves are called secondary waves or derived waves, which also move from east to west. Further, minor waves are generated from these secondary waves. These secondary and minor waves progressively move northward, though there is a gradual decrease in their magnitude and amplitude, but these waves generate tides everywhere. It may be pointed out that the primary waves are influenced by the moon, but the minor waves move freely. It is thus apparent that the tidal waves, after being originated in the Southern Ocean, progressively move northward with continuous lag of time and dissipation of the wave energy. In other words, the arrival of these progressive waves at successive places northward along the same longitude is also progressively delayed. Evaluation of the theory. According to progressive wave theory, the age of the tides increases northwards. In other words, if a tide is generated in the south on a particular longitude, it reaches quite late at the points located further north on the same longitude. Stationary wave theory. R.A. Harris of the US Coast and Geodetic Survey propounded the concept of the stationary waves as opposed to the progressive waves. This theory offers almost satisfactory explanation for local differences in the tides, their types and their age. According to Harris, tide phenomena are not due to the progressive waves which originate in the southern oceans as claimed by William Wavell, but due to the stationary waves which originate independently in each ocean. In other words, tide phenomena are regional phenomena. The stationary wave theory can be explained with the help of an experiment. If a rectangular tank or developing tray containing water is rocked from one side to other or is simply tilted, the water level rises along one side of the tray but falls along the other side. This generates oscillation in the water contained in the tray. Such oscillations in the water are called stationary waves. There is such a center in the middle of the tray where there is no change in the level of the water. This point is called the nodal point. The water level moves rhythmically from one end of the tray to the other, and along the line is called the nodal line. The period of oscillation of water in the tray depends on the length and the depth of the tray and the force of shocks applied to the tray. The aforesaid example is the case of uninodal system, but there may also be binodal oscillation system. Based on the above analogy, different oceans of the earth are like giant water containing trays. The tidal forces of the sun and the moon cause oscillations in the ocean waters, but the oscillations do not occur along straight lines as in the case of the tray. Rather, they occur around a central point because of the rotational force of the earth. With the result, several amphidromic points are generated. The oceanic water remains calm and stationary at these points, whereas water level changes around them. This mechanism results in the formation of the waves which move in anti-clockwise direction around these amphidromic points. Such oscillatory mechanism of water occurs in every ocean and is collectively called as oscillation system. Numerous stationary waves are generated from these amphidromic points. Every stationary wave has a definite time of its oscillation. The oscillation system and mechanism are affected by the depth, configuration and the length of the ocean basins and the rotational speed of the earth. The stationary waves, after being originated from the amphidromic centers, move towards their course. The forward movement of these waves is hampered by the continental peninsulas, islands, bays, etc. When these waves reach the coast, their crests and troughs cause tides and ebbs respectively. There is positive correlation between the depth of the oceans and the height of the tides. In other words, if the depth of the ocean becomes greater, higher stationary waves are generated and higher waves generate high or spring tides. Low tides are caused in the shallow seas because of the low height of the stationary waves. Water currents generated by the ocean tides. Water currents are generated by the ocean tides due to upward and downward movement of the sea level in the open and near shore regions. The coastward movement of the tides causes flood currents which pile up seawater against the sea coast. The currents caused by returning tides are called ebb tides. Thus, flood currents move coastward while ebb currents move away from the coast. The currents associated with tides in the open ocean are called rotary currents, which in turn counter clockwise direction in the northern hemisphere and clockwise in the southern hemisphere. When the rotary currents enter the shallow water of near shore areas, they suffer from friction and ultimately they change to alternating or reversing currents. The velocity of the rotary currents in the open sea is very slow, around 1 km per hour, but the reversing currents move very fast with the velocity of 44 km per hour. The reversing tidal currents assume greater velocities in the region of irregular coastlines, in narrow and constricted bays and in narrow coastal rivers. Tides are defined as a rhythmic rise and fall of the sea level under the influence of the changing attractive forces of the sun and the moon on the rotating earth. In today's lesson, we have dealt with the three different theories of tidal formation, the types of the tides, understood about the different positions of syzygy, conjunction, and we've also dealt with the formation of the ocean currents because of the tides.